Bright QT. Every student matters.
Hello students, my name is Sanjay Jain. In today's lecture, we will discuss about surface area of a right circular cone, right. So, in the previous lectures, we talked about surface areas of a cuboid, a cube, and then we spoke about surface areas of a cylinder and a hollow cylinder also, right. So, in this lecture, let us proceed with the knowledge of cone. So, what is a cone? A cone looks like this, right, and the base is circular. If you could notice, this is circular base, right, and this line is acting as the diameter of that circular base, right. Now, this is known as vertex, okay, and if I join this vertex with this base, this line here, then this angle is 90 degrees, right circular cone, that is, this is the right angle, the line joining the vertex with the base, okay, is 90 degrees to the base, okay. Now, the base is circular, hence this circular word, and this shape is a cone, right. Now, this radius is known as base radius. So, this is base radius, okay, and this is height h. This is known as height of cone, all right, and this slant line is known as slant height. So, this is slant height and it is, let us say, is denoted by L, okay. So, now we know the terminology. Let us look at the surface area. How do we look at the surface areas of the figures? By opening those figures, right. Now, if you open, let us say you have got a cone made up of paper. Now, if you open that paper, this cone would look like a sector. This would look like a sector of a circle. Now, we have studied about circles. So, you tell me, what will be this length? It will just be the slant height. It will be L, right. And what will be the length of this arc here? When you open this figure up, the base circle will open up and this arc will be 2 pi r in length, right. So, this sector is of a bigger circle, is part of a bigger circle now, okay. This is a small circle and this sector is part of a bigger circle in this particular case, where the bigger circle, that is this circle, has got a radius of L, right. When we talk about this sector here, the radius that we will consider is L, okay. Do not confuse the radius with R always. In this sector, the radius is L, okay. Now, if I consider this angle as theta, tell me what will be the length of arc? We have studied it in circle. See, theta by 360, 2 pi, here we write r generally, right, that is radius. In this case, the radius is L, okay. Now, length of arc in our particular case is 2 pi r. So, let us equate these. 2 pi r is equal to theta by 360, 2 pi L, okay. So, 2 pi, if I cancel, r is equal to L theta by 360, okay. Now, if I want the area, so what is the area of this sector, right? What is the area of this sector? Area of this sector, area of the sector is theta by 360 pi radius square. Radius in this case is L, so pi L square. Now, let us use this to calculate area of a sector. So, theta by 360 into L. If I separate from this, I will have pi L extra, right? Why I have separated this term? Because this term is equal to R. Now, if I put it equal to R, I can put it like this, R pi L, or if I write it like this, pi R L. This is the area of this sector. Now, if you notice carefully, this sector is just the curved surface area of this cone, right? So, curved surface area of a right circular cone with base radius R and slant height L is equal to pi R L, right. So, this is first result that we have derived. Now, the second thing, if this is L, this is H and this is R. So, this triangle, if you consider this one, this triangle here, this is a right angle triangle. Let me make it separately. If I reconstruct that triangle here, it is L, this was height and this was base radius, right. This angle is 90 degrees. I can apply Pythagoras theorem in this. Let us say I am given H and R and I want to calculate what is L. So, I can calculate L like this, L square is equal to R square plus H square, hence L is equal to R square plus H square, okay. So, this is what I am going to use here. Now, if I want to talk about total surface area of this right circular cone, then I will have to consider this circular base also, okay. What is the surface area of this circular base? It is obviously pi radius square, radius in this case is R, so pi R square. Now, if I write the formula for total surface area, then the base area, that is pi R square, plus the curved surface area, that is pi R L, okay, where R is base radius, L is slant height, okay.